Hi, my name is Milan and I turn coffee into code. In today's video, I'm going to talk about how we can implement an email uniqueness check inside of our domain. I'm also going to discuss what are some of the considerations and trade-offs that we need to make in order to implement this properly. We're going to start from the create member command handler. You can see that here we are instantiating a new member instance and we just add it to the repository and save the changes. But now a new business requirement comes in, and it says that before we register a new member, we need to ensure that no other member has the same email address as the member that we are trying to register. This means that we have to enforce an email uniqueness constraint inside of our domain model, and there are more than one ways to do this. I want to introduce two concepts before we start. One is domain model completeness, and the other is domain model purity. Domain model completeness means that all of the important business logic is completely encapsulated inside of our domain. Domain model purity means that our domain model does not reach out to out-of-process dependencies in order to be able to perform our business logic. The third component in this equation of completeness and purity is performance, and you will see that there isn't an elegant way to have all three. That is, we can't have completeness, purity, and performance at the same time. We can only choose two, which is kind of similar to the CAP theorem from distributed systems. CAP stands for consistency, availability, and partitioning. The theory says that you can only ever have two of these qualities. That is, you can only have consistency and availability while not having partitioning, or you can have availability and partitioning at the cost of consistency, and so on. So I'll show you how this concept of completeness, purity, and performance is kind of similar. Alright, so what do we have to do to implement an email uniqueness check? The first option is inside of the member repository, I'm going to introduce a new method. This method is going to return a boolean, for example. It's going to be called isEmailUnique, and I'm going to make it asynchronous. It's going to accept an email value object as the argument and a cancellation token. All right, so how we would use this inside of our create member command handler is before we create a new member, we say await member repository is email unique. We pass in the email result value, which is the actual email, and the cancellation token. The isEmailUnique method is going to return true if the email that we have specified is unique. So we obviously want to check the opposite case. If the email is not unique, then that means that the email is already taken and we should return from this method. Ideally, we would return some sort of error or throw some sort of exception so that the end user knows what happened. Let's consider what this approach gives us in terms of completeness, purity, and performance. Obviously, we are sacrificing completeness here because our domain model no longer encapsulates all of the constraints. Nowhere inside of our domain do we have a rule that now enforces email uniqueness, but rather inside of the command handler, we are checking that our email is unique, and then we are creating a new member. This means that we are splitting or fragmenting the domain logic between our application layer, where we have the command handlers, and our domain layer. This approach is generally fine. We still have domain model purity, where we are not contacting any out-of-process dependencies, and we still have performance because the email uniqueness check is very fast. It can be run against an index and complete very quickly. So this was one option. Let's consider another option where we will have domain model completeness and performance at the cost of purity. I'm going to go to the member class and I will create a static factory method that will create a new member. I will copy over the arguments from the constructor and paste them here. I'm going to copy the instantiation logic from the create member command handler and move them inside of our factory method. All right, we need to change the arguments here. So email, first name, and last name, and I also need to pass in the ID. All right, and now that we have a member, we can return it. So I mentioned that this time I want to keep domain model completeness and performance at the cost of purity. If you remember, domain model purity means that we are not contacting any out-of-process dependencies, so I want to sacrifice that to achieve completeness. That means that inside of this member create method, I need to have a way to check that the email that is specified is unique. I'm going to align the arguments vertically. I'm going to add one more argument to the bottom of this list, which is going to be the member repository. And I want to write that same check for the email uniqueness inside of the member create method. In order to do that, I need to make this method asynchronous. So it has to return a task of member. All right, and now I can call our repository and say if await member repository is email unique, pass in the email, and I'll not pass in the cancellation token this time. And obviously you have to check if the email is not unique, then we have to do something. In this case, I'm going to just return null, but probably the best option would be to return either an error result, throw an exception, or some other way to notify the end user that this email is already taken. So the way we would use this method is inside of the create member command handler, we can call member.create. All of the arguments remain the same. I pass in the member repository, and obviously we have to await this method. And as you can see, if we omit this previous check for the email uniqueness check, we have just one call to our member create method, which is completely inside of our domain layer. This method contains the logic for performing the email uniqueness check. So our domain logic is encapsulated inside of our domain layer, and we achieve domain model completeness. The performance is also all right, since we are only performing one check against the email field, which can run against an index. So it's going to be fast. But we are losing domain model purity because now we have an out-of-process dependency. I'm going to show you approach number 3, where we have domain model completeness and domain model purity at the cost of performance. I'll go back to our member method. It no longer has to be asynchronous, so I will get rid of this. All right. Now I'm going to get rid of this logic for the email uniqueness check and remove the iMember repository parameter. We want to achieve domain model completeness and domain model purity at the cost of performance. So how this would look like is we would receive a list of all of the members in the system, check if any of the members has an email to the email that we have specified in the member create method, and if they do, then we just return null, throw an exception, log some error, do something. Obviously this approach is the least preferred from the ones that I showed you so far, because loading all of the members from the database is going to be probably impossible in some applications. Imagine if you have 10,000, 100,000, a million users. This approach will simply not scale, and it will be practically useless for most applications. I'm going to show you one last approach where instead of passing in all of the members, I pass in a flag which is a boolean called isEmailUnique. Now instead of performing any complex checks across users, calling an out-of-process service, we just check this flag. If the email is not unique, we can either return null, throw an exception, log an error, or think of some other way to notify the user that the email has been taken. Back in our create member command handler, our member create method is no longer asynchronous. And here it accepts an isEmailUnique flag, if you remember. So I can call the repository here to pass it in. I'm going to move this into a variable so that it's more readable. All right. And I'm going to pass in the cancellation token because we have access to it. With this approach, we seemingly satisfy all of the three constraints that I just mentioned. So we have domain model completeness because we moved the email uniqueness check inside of the member create method. We still have domain model purity because inside of our domain, we aren't contacting any external services. The performance of the application is not in danger because we are performing an email uniqueness check, ideally against an index in the database, which will complete very fast. I think this approach is a nice compromise compared to the three previous approaches that I just showed you. The only caveat with this approach is that we have now tied together the process of creating a member and calling the member repository. So you need to somehow not forget that you need to perform an email uniqueness check using the repository before creating a member. If you want to get creative, the isEmailUnique method can return some sort of object that is supposed to represent an email uniqueness requirement, and then you can pass in this requirement into the domain layer. This object is probably going to be more expressive than a Boolean flag, and it's going to be a better way for you to not forget that you first need to call the repository before talking with the domain layer. I think that with this video we have nicely wrapped up the domain layer of our clean architecture. In the future videos we are going to focus more on the application and the other layers of the clean architecture, so I hope you're looking forward to that. If you want access to the source code that I used in this video so that you can write the code along with me, you can do that by supporting me on Patreon. If you like this video so far and you are loving the domain-driven design and clean architecture series, then consider leaving this video a like, subscribe to my channel so that you don't miss any of my future videos, and until next time, stay awesome.